Hey there, I'm Mina.
And I'm Daryl.
In this video series, we're going to take a closer look at the world.
Way closer.
We're going to uncover the hidden chemical changes that are responsible for the structure and functions of all living systems and support how we live. To understand them, we have to look deep inside.
From the macroscopic to the microscopic to the molecular and even the atomic scale. Today we're taking a close look at how carbon is transformed during everyday events.
Food, fuel, plants and animals, whether they're alive or dead, all contain carbon atoms and store or use energy.
We're going to do an investigation and look a little closer to examine what's happening on a very, very tiny scale.
Right, and today we're burning ethanol. All right, let's talk about ethanol.
Ethanol. It's also known as ethyl alcohol. Ethanol is an organic material, and organic materials are made out of molecules that include carbon-carbon or carbon-hydrogen bonds. Ethanol is very flammable, but why does it burn?
We're going to investigate what happens to ethanol when it burns. Here's what we're working with: a scale that's accurate to 0.01 grams, BTB, a clear container to put over the burning ethanol, and finally, we've got ethanol to burn in a glass petri dish.
BTB doesn't stand for bad to the bone? See? I drew a little mullet on the BTB.
Daryl, what are you doing?
Sorry. BTB is bromothymol blue. BTB changes color when carbon dioxide is added, like when you blow bubbles into it.
We can use BTB to see if carbon dioxide concentrations increase in the air.
Okay, first let's make some predictions.
The predictions should be based on our answers to the three questions: the movement question,
Where are atoms moving?
the carbon question,
What is happening to the carbon atoms?
and the energy question.
What changes in energy are taking place?
So, we can use the scale to detect any mass changes. If we make some accurate predictions about changes in mass, that'll help us answer the movement question.
Because if there's a mass change, then that means atoms are going from one place to another. So, what do we think will happen after we light the ethanol? What will gain mass? What will lose mass?
Changes in BTB can help us answer the carbon question.
After 20 minutes, what kind of color changes should we expect to find in the BTB? And what would the color change tell us about what is happening to carbon atoms?
And finally, make a prediction that relates to the energy question. What forms of energy are involved? How is energy changing from one form to another?
I'm sure you have a lot of other burning questions.
Oi. Let's pause the video now as you discuss the following questions. What changes in mass will you observe? What changes in the BTB will you observe, and why? And how is this related to the movement question, the carbon question, and the energy question?
All right, well, thank you so much, Nina and Daryl. This is Mr. Fostering. Welcome to my laboratory, also known as my kitchen in my house, because it's COVID and that's the type of thing we do. So before you make your predictions, I want to make sure that you're really clear on the setup for this investigation. You'll see here that I have ethanol in a petri dish. It's placed on top of this scale here. Right next to it is the BTB. It's kind of a greenish color to start with. Remember that if the BTB, if more CO2 is going into the air, the BTB will turn yellow. If CO2 is leaving the air, the BTB is going to turn a darker blue. And then I have a bowl. After I start burning this, I have a bowl that I'm going to place over the top. And so what's ever happening with the ethanol burning will stay inside of here. The chemical reaction of combustion is going to be contained in this bowl. So your predictions are going to need to answer the three questions. Where's matter moving? So is matter going into the ethanol, out of the ethanol? What else is happening with matter? How's it moving? We can answer that by changes in mass. We're also interested in how's matter changing. If a chemical reaction is occurring, how are atoms being rearranged into new molecules? The BTB can tell us a little bit about that. And then finally, we're going to be making observations about energy as well. And we can actually sense energy with our sight or by feeling heat. So I'll go ahead, walk through these predictions with you, and then we'll get back to this and I'll show you what happens when the ethanol burns.